This is a Toshiba Portege. It's the 610 CT. That's the second generation of Toshiba's sub-notebook series. Long before ultrabooks and netbooks, we had sub-notebooks. I find these machines fascinating. Today we're going to dig deep inside to see how it's built and examine the state of the art in superlight computing from 20 years ago. To make smaller and lighter machines, you had to make some pretty significant engineering compromises. You could keep at least some of the same capabilities of contemporary desktops and laptops, but something had to go. With this Toshiba, you got a scaled version of their larger models, but with first-rate features still. In other ways, it was equivalent to their premium models. The battery was lithium-ion when nickel-metal hydride was the norm. It was a Pentium 90 in a world of 46s. The hard disk was somewhat small, even for the day, at 720 megabytes, but the screen is only scaled down to 9.5 inches, and it's TFT. The keyboard is quite scaled down. Just look at it in comparison to the MacBook Air. If we look around the sides, the typical internal floppy is missing. That has to be tethered externally. There's no CD-ROM, of course, and the big hole is a missing cover for PCMCIA cards. It supports two, which was pretty typical. In the back there's just a serial port, parallel port, and a place for a port replicator. And that was the only way to plug in monitors, keyboards, and mice. On the other side, you get sound jacks and a power button. You can also see where there are little fold-down feet to prop it up. The Portege is smaller, but it does carry a premium price. I was only able to buy this one used. New, they started out about $3,900. Obviously, I was persuaded by Toshiba's engineering take on the compromise, but you couldn't have massive paws and use this machine. My own experience was that for most Windows 95 early adopters, they'd be able to use it perfectly well. So what kind of origami did Toshiba use to shoehorn everything into this little box? Let's take it over to the workbench and find out. First up, we need to pull out the battery. It's a 4,000 milliamp hour lithium-ion pack. That gives us access to some hidden screws. We'll pull all the screws out from the case bottom while we're here. There's also this trap door covered with a Toshiba warranty sticker. That's where the RAM upgrade hides. Flip the machine over. Now back on top, you start by prizing out the trim panel below the spacebar. Under it, you'll find a number of screws holding the keyboard in place. Slide the whole keyboard assembly forward just a little to disengage the tabs locating it at the back. Lift it gently so that you can see the two flat flex cables and their sockets. The one on the right is for the keyboard itself, and next to it is the one for the pointing device. Toshiba's name for that button thing was the AccuPoint. As I lift out the keyboard, underneath you'll see an empty hard drive caddy. Normally that should contain a slimline 2.5-inch IDE disk. The default load was Windows 3.1 and DOS. On the right, you see the tops of the PCMCIA slots. On the left, you can just see the CPU heatsink peeking out from the back. To open the case now, I need to unplug the rest of these cabled connections. The gray wire is connecting the microphone to the sound card with a 2-pin plug. The screen accounts for most of the other plugs at the back right. There are 3 smaller connections for the speaker, sensors, and display backlight power. Then there's that flat flex connecting the status bar. I'm just easing the top case shell free and setting it aside. Under it, you can see the sound card at bottom left. It's stacked right over the power supply board. Over on the right, there are 2 batteries missing from this picture. An earlier attempt to revive this machine led to the discovery of clock and backup batteries, both dribbling diseased goo. Okay, we're going to pull this sound card out. I've taken out the single screw that goes through the shielding. Last step is to pry that flat flex free. The card needs to be slid to the right and lifted for that volume knob to clear the case. Let's have a closer shufty at it. The main chip is this ESS Audio Drive Sound Blaster Pro compatible device. Now that's a 16-bit stereo capable thing. The board also carries these 2 mouse buttons. I'll flip it over. On the other side you have a Yamaha sound synthesizer chip. Back to the main system. Next you have the power supply card. The contacts for the main battery are mounted directly on this board. You need to lift out this little gray blanking block first. Then you can pry the surface mount plug away from the main board. Okay, looking at the board more closely, we can see that it has a microprocessor to manage the AC adapter, battery, LED indicators, and to do internal PSU tests. Over on the board's other side, This thing here is a dedicated lithium-ion battery controller. I'm puzzled about this device here, though. I can't find a datasheet for it. Returning to the main assembly, we'll just take that CPU heatsink and that shielding off first. Then we can have a good look at the system board. Compared to other machines I've looked at from this period, this little Toshiba uses a lot of custom integration, rather than the off-the-shelf components. This allows it to have a much smaller board footprint. Some of it's done as gate arrays, but there's a bit of custom ASIC too. The processor is hiding behind that gold heatsink. Right next to it is a gate array acting as the CPU's control glue. It's the memory controller, and it joins together various buses in the system. This system controller connects off to the ISOBUS controller and also to the graphics controller. Those are both on the reverse. Over in the back you get a better view of that Pentium 90 processor. The graphics controller is the chips device. This does 1024 by 768 resolution externally, if you can live with 256 colors at 48 Hz scan rate. Otherwise, it's driving the internal screen at 640 by 480 and 16 million colors. It's got 2 video RAM chips next to it. Here you can see the ISOBUS controller. It's right in the middle. It's made up of another gate array. A bunch of them use that general-purpose I/O controller. This is a custom ASIC and it's at the bottom right. That does floppies, serial, parallel interfaces, interfaces with a PSU microprocessor. It also provides DMA, bus interrupt control, and programmable timers. If we move up just a little, you get the PCMCIA card controller. The documentation says this should be another custom gate array. Now turning back over one more time, you see some of the other device controllers. There's that PEGI 2, which is a custom I/O controller gate array. Then there's the keyboard controller, which is managed from this, as is the soundboard and the BIOS ROM. They all exist on the same little bus, using the PEGI as some kind of glue. Well, that about does it for the main board. Let's move on to the screen. The case is mostly snap-fit. The multi-core video data cable converts to that flat flex right there at the case bottom, and then that spans the back of the panel. Both the panel and the backlight supply are Toshiba's own. That's about as far as we can tear this one down. I love the build quality of this thing. It survived better than a number of other contemporary machines that I own because of the better plastics and hinges. It's buttoned back up, but sadly no longer working. As of now, it throws a power board error that probably relates to either the missing backup battery or damage caused by a leak from that battery. And that means it's on my repair backlog. Perhaps this is a subject for another video. I hope you found this teardown interesting, and for more in this teardown series or for videos on vintage computer topics, please give Beige-o-Vision a subscribe. And if you liked what you saw, please give us a thumbs up too. See you soon.